So welcome back to channel guys. Hope you are doing extremely well, and this is linked list lecture number 17. Quite a long series, right? So the question for the day is sort a linked list containing 0, 1 and 2, right? Given a linked list, it can only contain 0 or 1 or 2, and you will have to sort it. Now, whenever you hear like you have to sort it, the first option should be that I literally solve it. Like I will apply any sorting technique such as merge sort or quick sort, and that will be my first approach. But the problem is we have not yet understood the any of the algorithms such as merge sort or quick sort in the linked list, right? So what do? We will actually try to apply our mind. So we have been given that the linked list only contains 0, 1 and 2. The linked list only contains 0, 1 and 2. So our mind should say that it is pretty evident that all the nodes with 0 will occur first. All the nodes with 0 will occur first, followed by 1, followed by 2, followed by 2. So the algorithm I have in mind is if we actually count the number of zeros, such as we declare a variable 0 and we have the number of zeros in the linked list. Similarly for 1 and similarly for 2. Now we have got number of zeros, we have got number of ones, we have got number of twos. What do we do now? We now traverse the linked list. We now traverse the linked list, right? And just don't do anything else. First 0 nodes will be 0, followed by the second, like the number of n one nodes will be 1 and number of 2 node will be 2. So what I'm saying is I'm actually saying that I will keep a temp here, that is temp, let us say this is temp pointer, and I will declare 3 variables. First 0, 1, 2. All of them initialized by 0, 0, 0. I will move my temp such that if temp data equals to 1, I will increment my 1. So it becomes 1. Temp comes to next. Temp data equals to 2, increment your 2, becomes 1. Temp data equals to 2, increment your 2. Temp data equals to 1, increment your 1. Temp data equals to 2 again, so increment it. Temp data equals to 0, increment it. Temp data equals to 2, increment it. Temp data equals to 2, increment it. So we have 1 0, 1 1 and 5 2's in the linked list. Now my algorithm says again do it, that is temp equals to head, that is I have to do this step again, that is temp equals to head. My temp will again come to this position because this is my head, right? This is my head. The first order of the linked list is the head. Now my algorithm says for the first 0 number of nodes, it will be 0. So that means it is 0. Change the value to 0 here and move your temp to next. Temp comes here and you can see my 0 has now turned to 0 because 0 minus minus. 1. For the first, like for the number of 1 nodes, create it to 1. So 2 becomes 1 now and temp comes here. Now for the remaining nodes, you can actually do that for 2. So it becomes 2, temp comes here. It becomes 2, temp comes here. It becomes 2, comes here. 2, 2, 2, and you can see my linked list is now actually sorted. So how will you proceed after temp equals to head? We will say while my 0 is not equals to 0, right? What do I do? I will say temp's data equals to 0 because we used a 0 0 minus minus, and temp equals to temp next, temp equals to temp next, right? Temp equals to temp next. Similarly for 1, the same loop for 1 and the same loop for 2, but they will be occurring in sequential order. This will be the first loop, this will be the second loop, and this will be the third loop, right? And you will actually get the sorted linked list, right? If you would have used sorting algorithm, then it would have took around n log n time, right? We know about that sorting actually takes n log n, not less than that, right? But right now it is taking of 2n time, one for actually counting the number of 0 1 2 and one for actually filling them. So it is actually more optimal, right? So our algorithm is actually clear to us, and it is also using constant extra space, right? Okay, so now it is time for us to see the code. I know the video for today, the lecture for today is actually very short, and I have no objections for that as far as you are learning. Okay, so let us to move to the code now. All right, so here is the coding section. This is the GFG platform I am using because I was not able to find a linked list lead code platform for this question. Okay, so let us start by doing it. So before starting, I would like to request you to please subscribe to my channel. Okay, so int 0 initializes 0, 1 initializes 0, and 2 initializes zeros, right? After that, I will create a temp for traversal and point it to head. The question is actually very simple. We have dealt with the difficult questions also, right? Now while my temp is not null, what will happen if temp data equals to 0? In that case 0 plus plus, and I will just copy it for 1 and 2. Else if, this will be a space here, else if temp data equals to 1, it will be 1 plus plus, and similarly for 2. Else if temp data equals to 2, increment your 2, that is a counter for 2. It will be 2 here, right? And after all of these operation, I will have to just move to the next. So temp equals to temp next, temp next, right? This is a simple traversal. Now what will happen? I will say my temp is equals to head again, and now while my 0 is not equals to 0, that means I will do something like this: temp data equals to 0. Because we use a 0, we will decrement the counter, and now temp moves to temp next, right? Similarly for 1, I will do 1 temp data equals to 1, 2 minus, 1 minus minus, because we used up a 1, and temp equals to temp next, right? Moving on, I will do the same for 2, while 2 temp data equals to 2, and then 2 minus minus, and temp equals to temp next, right? By the end of the third last loop, your linked list will be actually sorted, and you can actually turn your head because you are actually pointing to the sorted linked list head. Let us try to compile and run it. Hope it will work fine. And if it works fine, you will have to subscribe right away. Okay. So it is running fine, and it is time for you to submit the code and see if it is running for the backend test cases as well. It will run most probably. It is running fine, and as you can see, we have just completed. And thank you for watching. We will meet again in the next lecture, which will be uploaded tomorrow, so please make sure to watch that. Okay, thank you, have a nice day.